So today we are going to study certain things about the releases, the beam releases. What are the effects of the beam releases are there in a particular project? When to do, why to do, how to do, what is that effect to the structural changes? Okay, what are the different types of releases are there? What is partial release, partial fixity? Right, so this is the release function. What are the beam releases means? So whenever there is a release button is there, this dot which represents the release. Whenever you are dealing with the model, let's say any particular ETABS model for that sake. Now you need to give certain releases at some places. Let's say these two beams are the real beams. I'll just give some property to that beam. Let's say this is the concrete beam. I need to unlock this model and then I'll give this as a concrete beam. Now, and these two beams I need to release it. Release it means what happens is the fixity would be it will not be the fixed at these two ends. The other two ends it will be released, means it will be the simply supported. We'll get into that in detail, right? So how to release it? You go to the assign frames and the releases, this option, or the partial fixity, and you give the releases. Generally the release button, which is moment 22 and moment 33 directions are there. So we'll see what is 2233 torsion and the sign conventions and all actually, and we'll give the release button over here. So you can see that this is a dot. Now this dot represents basically the release button. Okay, so M2 and M33 and torsion. So if you know we have seen the local axis coordinate system and the global axis coordinate system, if you remember that. Let's say for example, if this is the I section and the force is acting in this direction, so this is always 1 1. This is R, which is we call it as 1, direction 1, which is in R means the red in color. So I'll not give this as a red. This is 1, direction 1. Then G, which is green color, that is direction 2. So this is direction 2, and the B, which is blue in color, that will be direction 3. Alright. So these are the local axis coordinate system of a particular element, whether that is a beam element, whether that is a column element, or whether that is a brace element. What is beam? This is beam, this is column, and this will be the brace elements. So in all the three cases you will see that the local axis coordinate system is uniform, 1, 2 and 3. Okay, so if you are getting confused with this, I'll just try to tell you that imagine that this is a beam. This is a simple the scale. Imagine that this is I section. Alright, so in this beam what happens is whenever you give the load on this beam, what will happen? This will start bending in this direction. Now this bending will be, if you take the circle of this the center of the circle, where it will be here. Okay, so this particular axis is 3, this axis is 1. Okay, so M11 is always the torsion. Alright, this is in this direction it is 1, in this direction it is 2, and in this direction it is 3. So whenever you are giving the force on this beam, what happens is the bending moment will be about the 3 direction. Okay, so this is 2 direction, this is 3 direction, and the torsion is like this. This is the torsion. Alright, so this is what we have seen this over here. So here you can see that this is M22. So the bending moment about this 22 direction is this. So this is 22. 11 is torsion. M22 will be the minor bending moment, alright, and M33 will be the major bending moment. Alright, so as you know that, let's say for example, if I give any kind of load on this beam, imagine that there is a support here and the support at the other end, it will start bending about the 3 direction. Alright, so it will start bending about the 3 direction. So this bending moment is the major bending moment. Okay, so whenever we are releasing it, when we come to the releasing option, what we need to do is, let's say for example, in this case, the case 1, okay, in the first case, what will happen is, this is a fixed beam. Let's say this is beam B1, beam B2, and this is beam B3. So I'll just draw it here. So if I ask you that you please draw the bending moment of this when there is a uniform load system for this, how do you draw it? Okay, the bending moment of, let's say this is B1, this is a fixed beam. So obviously the bending moment will become something like this. Alright, so, and if you take the B2 also, it is similar to this. So this is B1 or B2, and when it comes to the B3, you want this bending moment would be somewhere like this. Alright, you want this bending moment to be, I'll just draw it with the dotted diagram. Why? Because this is like a simply supported beam. So obviously you will see this WL square by it. Why? Because the loads which are coming from here, let's say the actual loads which are coming from here, it will be, added on this in the 3D diagrams. Okay, on this beam and on this beam, B1 and B2. So we want this to happen. We don't want any of the bending moment. The moment if you take this as a fixed, imagine that this is fixed here. Instead of releases, it is fixed here. So what will happen? This bending moment will get reduced and it will be added here and here. Understood? So are you going to give the top steel here? Now let's take the detailing of this beam B3 so that you will understand this. So let's say the beam B3, I am going to detail it. So how do I detail it? Let's draw it. And from here there will be another shape. I'll just imagine that this is the beam that you guys are having. This is beam B3. Now this is the section of beam B1, the cross section, and this is the cross section of B. So you are taking the section like this. Alright, so once you do something like this, what happens is you will see the reinforcement inside this. So let's draw the reinforcement rebars also. Alright, so how it will be? It would be, is it like this? Is it like this? No, it will not be like this. Why? Because this is a beam. You will not be anchoring inside this. This anchorage, we will not do it on the side. This anchorage also will not do it on the side. So how it will be in realistic way? It would be something like this only. Let's say I'll put the rebar like this over here, and I'll put the rebar somewhere like this over here, and there will be certain stirrups here, and there will be certain stirrups over here. So you might be thinking that this might be a slab, but no, consider this as a beam B3, although it looks like a slab. But this beam, I'll just zoom in a little bit so that you will get it more real. So if you ask me the anchorage length of this, you might be knowing the embedded length, anchorage length, and anchorage, or let's say at this place, how to see the anchorage length. From here to here it will be the anchorage length. So imagine that beam B2 will be having 230 as the width. So can you provide the 50 times the diameter of the rebar, the anchorage length? So it is impossible to provide that much amount of anchorage length. So that much amount of the bending action, the resistance of bending action will not happen. I hope you are in sync with me. The resistance, see, if you are having the bending moment like this, let's say for example, if you are having the bending moment like this, the tension will be going from here to here, and it has to be resisted by some kind of force. Since it is going in that direction, the resistance force should come from the other direction, which in terms of the anchorage. So such kind of things doesn't happen. Why? Because you are not getting that much amount of anchorage length here. That is not possible. Whereas the same case, I'm just copying the same thing as a beam, as a column, sorry. So what I'll do is I will consider this as now it is a column. So imagine instead of beam B1, it's a column. So in the case of column, what happens is you will have, let's say this will go straight like this, right? So similarly here also it will be something like this over here, and it will be something like this. Imagine that this is now it is a column, and this is not beam B3, this is beam B2 or beam B1. Okay, so this also I will, okay, so what I'll do is I will give this as beam B1 or beam B2. So if you see my previous diagram, beam B1 and 2 is what? It's a fixed beam. Am I right? If you see this beam, this is a fixed beam. Alright, you can see that up. Alright, so this particular beam, what happens is it's a fixed beam. So there is a column here, right? So in such kind of situation, the bending moment has to be naturally, it will go like this. Now the same question arises, do we have the anchorage length? So in such kind of cases on the site, if you go to the site engineers or the bar benders, they will do this L on the site. What they will do is they will do this L, and this L also will be generally in the range of 50 times the diameter. Why? Because it's a tension anchorage. Since you are getting the space basically from here to here, you are getting that much amount of distance from this fiber, okay, because the resistance will occur. Imagine that there is a huge amount of vertical force acting on the structure, vertically down, amount of it is going down. So in that case what happens is the bending moment. So in this case you can see that the bending moment and all, you will get a lot of space for the resistance. This much amount of space you are getting for the resistance. Alright. So at this place it will be fixed only. This is fixed connection. This is also fixed connection. Alright. So if this is a fixed connection and all, so how do we take care of all this in the mathematical model? So if you go here in the mathematical model, the fixed beam is nothing to be released. It will be just going down straight away. Only the releases will happen at the simply supported beams. In a simplistic way, let me tell you very honestly, in a simplistic way, whenever there is a column, look at this, there is a column there. There is a column here, there is a column here, there is a column here. If there is a shear wall also, it will act like a compression element only. Alright? So once you have such kind of the system, it will give the resistance for the bending. So the beams which are connected to the columns and the shear walls, you will give that beams as a fixed beam. Means you will not give any kind of releases. By default, all beams are fixed beams. Please remember this. By default, all the beams are fixed beams. Understood? So you don't need to give releases there. You need to give the releases only at the simply supported beams. Now the problem arises when you are having partial releases. Now there is a function here. What's this partial release? How do we give this? So can we give this 0.25? So 75% releases is happening, 25% release is not there, or maybe reverse or something. If you give 1 here, what will happen? So please understand this. This is the kilonewton meter / radian. Now this is really crazy. Now what is this? I'll tell you. You need to get the rotational moment of inertia. Now this is something different which I wanted to tell you in detail. What do you mean by rotational moment of inertia? Anybody? Now this is, see what happens is many students, now you will see the mathematics M1, M2, M3. The pain in the ass. Right? Why it was like this? Because all these concepts are required, my dear. Yeah? So, let's say if you go here, you require rotational moment of inertia. What does that mean? Now please be careful, understand this. See, whenever there is a beam here and the column here, and whenever there is a bending moment, you require certain things to resist. Whenever there is a force going, imagine that there is a tension, there has to be resistance that will be offered by the reinforcement which is coming inside. That will be offered by the, just now as I told you, resistance in terms of the anchorage that will coming inside. Now in this war footing, this is a war only. What is war? There is a force and there is a resistance. Now imagine that there is a huge amount of force is there, but resistance is only partial. It is not fully like this. It is only partial. Then what happens? This much moment will release into the torque. It will start spinning. It will start rotating. Do you agree? So that much amount of rotation will occur. How it will be? Like somewhere it is, I will just draw it with some different color so that it will be easy for you to understand. Maybe it will be something like this. I'll draw it in a bigger pen. The work will happen. Are you getting? Now this is because you are giving the only this much amount of resistance. If you want to, this is known as partial release function. What is it called as? Partial release function. So for that, what you need to do is how much amount of force that you are applying and the amount of resistance, which is known as rotational moment of inertia, you need to calculate in the 3D space frame analysis. In the 2D, yes, it is little bit okay. It is possible, at least you can calculate with certain stiffness matrix and all, and you can just put these values over there. But to calculate these values, it is very, very difficult, and I would encourage you not to give any values over here. It should be 0 only. Understood? How much it would be? 0. Do not give any sort of values here. So either it is because you don't want such kind of behavior, am I right? Do you want such kind of behavior? No. So what you do is, you give full release or you give zero release, fixed or fully released. Simple on the side. Now, in order to imagine that you want this behavior which is partial release. Okay. So how do we do that on the side? Imagine that in the worst to worst situation you want to have such kind of behavior to release some amount of bending moment. Maybe sometimes this particular bending moment will be converted into the bottom bending moment of the beam instead of really giving the torque. If that is your argument, how to do this? Instead of the 50 times the diameter of the rebar, you will give only, let's say, up to certain extent. You need to go only here and only up to here. So some bars will come up to here, some bars will be coming up to here. So how difficult it is on the site. Imagine that you are a site engineer. Some bars you need to take it as a L, which is 50 times the diameter of the rebar. And some bars you need to take, let's say, around 35 times the diameter of the rebar. On the site engineer will get annoyed also, because it is very difficult to do it on the site. It's easy to make it uniform everywhere and just finish it off. But partial fixity, it is not possible to do it on the site. So that's the reason you consider this effect as a zero, or you give certain, or you unclick this option to consider this as a fixity, like, it is there over here. Are you getting what I'm saying? Okay. So this is what actually the partial release function which I wanted to tell you. Now, still, if you want to have such kind of behavior of certain partial release, you go to the stiffness modification factor. We call it as SMF. Okay, where it is even little bit more under controlled. Okay, where it has to be done, how it has to be done. Okay, I'll not touch many topics on in today's, otherwise it will be confusing for you. But stiffness modification factor means you go here. We'll be taking a very separate session for this, so don't get tensed. Okay, you go to the modify the property here, and there is an option here. We call it as the stiffness modification factor. So if the release, torsion release, if you want to do, let's say 25% of the release you need to do, so you give 0.75 here. So this is much more control, and you don't need to take the headache of the calculation of the rotational moment of inertia of this beam, this beam and the column over here. Understood? So this is also releasing function only in a little different way. We will come back to you on this when we will start with the stiffness modification factor. Alright, now this is about the beam releases. What about the column releases? Let's say, for example, I'll just hide a few things, like let's say the walls, null shell elements also. Yeah. Let's say, for example, I wanted to have the roller support here. So how do we, connect this? You need to have some kind of element, or let's say, for example, there is no column here. I'll just delete it. And I'll give this as a zero restraint. So there are no restraints also. I'll just delete this. Now this column is a transfer on this beam. Alright. So I need to release this because I may not be able to give that much amount of fixity because it is coming from the beam. So for this column also, I have also done many a times that for column also you can give the releases at the particular edge. Do not, you are giving it M22, M33. Okay, if you give this over here, you will see that it is happening at the start end also and at the end also. So don't do that, because here you don't want that release to happen. So At the end, just remove this and give this. So it is at the start, means it is fixed here, this column is fixed here, but this column is released here. Okay, so whenever you are giving the such kind of transfer girders and all, so what do you do is, so in such kind of cases, if I want to detail it, I'll give the rebars like this, and I'll give the rebars here at the bottom, and the another beam rebars will go like this. And the top rebars also, it will go like this, where this is, your column. Here you will be having the stirrups, and here also you will be having a closed space stirrups, because you don't want this to have the, so this is, what is this? This is the transfer beam. So in such case also, what happens is, imagine the anchorage length will be from this fiber down. Now this is basically the anchorage length. So you will not get the enough anchorage at this place. Whenever there is this is floating column. This column is this column. This beam is this beam. Understood? Because as you are having the column down, there is no column here. I have deleted the column here. Understood? So in such kind of cases, this has to be rested on the same column, the same beam. So in order to have such kind of behavior, the anchorage length will be very less compared to the foundation. Even if you increase it, it will not help you out. So in such kind of cases, what I'll do is, I will make sure that it will take only the PU. I will not consider the bending moment of this. Understood? Whatever the forces are there, please transfer the forces. So like bending moment diagram will be somewhere, this particular beam element, the bending moment diagram will be somewhere like this. It will be 0 here. And for this column, the BMD of column. Which column? This column. And this is, your bending moment. So it will be maximum here and it will be 0 here. Why 0? Because I don't want this anchorage to go down. I cannot increase it. So if such kind of situation is there, that time what you will do is, you go here in the E-types model, and in the model you give the releases at this place. How to give that? You just select this, you go to the assign frame, and there is a releases option. Assign frame and releases option. So once you go here, you will select only at this point or this point, whatever the only start point as torsion. I don't want minor bending moment also. I don't want torsion also. I don't want minor bending moment also. I don't want major bending moment also. At this edge, I will like to have it this edge, but I would not like to have this edge, because there is nothing to resist here. That sturdy foundation is not there. This is a transfer girder. This is not a foundation where you will get the base from all the sides, so it will have the resistance in this direction also. It will not move in this direction. It will not. It is just a tiny beam which will probably take only the vertical action, but it will not give you the resistance against the bending. Okay, like this. So what I'm saying is, in such kind of situations, for the columns also you require such kind of facility. Now imagine that there is a brace element. Then what to do? So what is brace element? This is the brace element. Imagine in case of the steel structures and all, when we'll take certain steel structures into consideration, during that time you can apply this kind of concepts in detail. So what you do here is, let's say for example here I am giving this ISHB, such kind of sections. And in such kind of sections, do you want this to take the bending action? No way, right? So what you do is, you give this as a releases. In both the cases, so that it will behave only part of the compression and tension elements. It will only the compression or tension. It will not start rotating. Understood? So this is the behavior. The only thing is you need to go for the non-linear analysis to give that action. And another thing is, if you go here, you need to give the tension and compression limits. You give certain limits to the tension and compression. Whether certain elements you require the tension element only. In that case, you tension limit you give unlimited, compression limit you give 0. If you give 0 as a compression limit, means it will be a tension element only. Understood? To clarify a little bit more, I would like to just show you. Let us say that you are having this kind of truss here, and there is a force here. Now, whenever there is a force, you know that there is a compression here, right? It would be a compression. You don't want this to take the tension. Imagine that there is a tension like this, also factor is there. So in that case, what you will do is you select this element and you give the tension element as 0. Similarly, whenever the force is here, this particular element will start going in that direction. So there will be the tension here. So compression will not be there. So in such kind of cases, you can give the compression as 0 limit. Okay, so like this kind of things you can do it. Or in the reverse case, in the very worst situation, let's say for example, you are applying the force here, but you don't want this element to be considered as a compression element. Why? Because you want this elements to be rotated, and this is just the tie connected to this column and this column. Okay, you don't want this to consider any sort of compression and tension action. The action which is the moment action and all. So it is just the truss element which is just tying these two elements. So this limit function you need to give. The only thing is, please, this is very important. Only thing is, what you need to do is, once you give this, you need to go to the, let's say you are applying the dead load or any particular load, you need to go for the non-linear analysis. From here you need to go for the non-linear static, because it is an iterative method. What it is? It is a iterative method. So that's the reason you need to go for the non-linear static, where some p delta and other functions will be coming into the play. That time it will do the tension element and compression element. So this is how actually you will do the releases option in case of the brace elements. Understood? So we have seen the action when there is a small beam, the simply supported beam, continuous beam and all. We have seen the releases option in the column and the releases option in the cross elements, the brace elements. Understood? Got it? So this is how the release function is coming. One more thing is, if you want to release the slab, for example, I want to release this slab. So what you do is you select the slab first, then you go to the assign, go to the slab here, and there is a beautiful option over here. We call it as the edge releases. Understood? So you go to this option, edge releases, and you can go to any particular option over here. Let's say for example over here, edge releases at a particular edge. So you can give the edge numbers, and then you can give the certain amount of releases. It is the same thing, 1 1 2 2 3 3 the option, and once you give that, you will see that at this particular edge the releases is happening. This is one edge. You go to the another you select this same thing, and you go to the edge releases button. You go to the, let's say for example, the next one, and then you go to some particular these functions here and just apply. So it is shifted from here to here. Alright. So this is how actually there is a get values currently from the selected objects, and many other functions are there here. I'm sure that if you can spend some 20 minutes on this, you will get to know this. This is in plane force, this is out of plane force. We have already taken a lot of sessions in the in plane, out of plane stiffness and all. You just spend some time so that this edge releases functions also you can utilize it from here. Where do you use is whenever, let's say for example, there is a beam here or a slab here and a beam which is going down. This is a beam which is going down, and there is another beam which is like this. So this bending moment will never go to this. The bending moment coming from this slab will never go to this slab, right? Like this it will not go. So in such kind of cases, what we do is the bending moment of this will go to the beam, not to the slab, because this is not a continuous slab. What is this? This is not a continuous slab. So what we can do is, in this kind of cases, this is like this is like this. Okay, so the kind of arrangement that we need to do it over here is, this slab will be having the release function here, and this slab will be having the release function here at this edge. So like that, what we have given it like this over here. Right, so in the model it will be at one plane only, one edge only, but you will give the mathematical release at this function like this. Understood? Okay. You just need to practice this so that it will be very helpful for you. Please understand that whatever the functions I am telling you here, it is same, it is available in the SAFE, it is similar, it is available in the SAP 2000 also, in many other softwares also like CSI Bridge and all. That's why I'm going very slow. As I told you that if you are knowing the ETAB software fantastically, the operational level for the other softwares, it becomes comparatively easier. Okay, now we'll start with the certain doubt clearing sessions. Okay, so please, if you want to ask any of the doubts, the time is now. Please ask the doubt. I'm allowing you to unmute yourself so that you can ask the doubts. Yes, guys.
Hello, sir.
Yes, hello. Please on your camera, everyone. Thank you.
Hello, sir. Good afternoon, Mahesh here.
Yeah, Mahesh, tell me.
Sir, if you have a wall,
Okay.
shear wall on the floating girder,
Okay.
so how we can release that bottom if you don't want the movements and
Shear wall, you unfortunately releasing option is not available.
okay.
Probably in the latest version they might have changed it. It's a very good question. Let me show you. Imagine that let's say over here I'm giving certain shear wall at this place. I think that option was not available before. From here to here we are giving a shear wall to all the floors, and now let's say this shear wall, you need to give the release option. So you select this shear wall and then you go to the edge releases option. Yeah, it is there, sorry. It's there. It was not there in the certain previous versions, but they have added it. But use it very carefully, okay, because shear wall releases is very dangerous option. Okay. Okay. Any other question? Anybody? Yes.
Sir, yesterday what the process and assignments given,
Yes.
in that case, sir to releases for trust, releases to every member.
Okay.
But
Then you give the releases. If you, but you need to give that actually after giving the releases, you need to give the tension and compression limits also. If you give tension limit as 0, it will become a compression element.
Okay, but when we run the analysis, it gives the instability.
Yeah, probably you might have given the space frame in that case. See, first thing is, in the yesterday's module, we have given one truss actually. So what you do is you go here,
Yes.
and here you need to give XZ or YZ plane. If you forget this, then if you go to the space frame, then it will give you the instability warning. But if you go to the XZ YZ plane, it won't give you. Just check it out. Even though after giving this, if it is showing you or if it is giving you warning, then you can show me the model. I'll just look into it. And one more thing is, I told you, since you are giving tension and compression limits, you need to go for the non-linear analysis. Otherwise, it won't take it. I can give you the example, not now, but maybe a little later on. You need to do the non-linear analysis for that. Okay, any other question? Yes? No questions?
Hello, sir.
Yes? Yes, Sabdar?
Sir,
Okay, you can carry on, no problem. Yes, Sujan.
ये सर जब हम बीम रिलीजेस देते हैं सेकेंडरी बीम में रिलीजेस देना आता है, लेकिन जब टर्शियरी बीम से टर्शियरी बीम और उससे ज़्यादा बीम आ जाता है, तब कौन सा बीम में कैसा रिलीज दे वो कन्फ्यूज हो जाता है सर.
कंफ्यूजन हटाने के लिए आपको, सी इफ यू आर गेटिंग कंफ्यूज, डोंट गिव रिलीजेस एनीवेयर. Try to see the natural behavior of the structure. Whatever the beams that you are giving, is it how much bending moment it is taking and all. Actually just check the natural behavior. If you give the fixed every element is a fixed element unless and until you give the release option over there. Alright, so what you do is, I would like to suggest you that you give the fixed option, you run the analysis if you are getting confused, and then check the behavior, that which is primary, which is the force is transferring from primary to secondary, from secondary to primary and primary to the main frame elements, and then it goes to the columns to the foundation. So load path decision is little difficult at the initial phase of the career. I know that it's a it's difficult task, but you need to deal with this. How to deal with this, I'll tell you. You give the releases, don't give the releases, you run the analysis, get the results, and then you apply, okay, I will consider this as a primary, this as secondary, something like that. So you will fix up the load path based on the natural behavior. So you don't make the Sachin Tendulkar as a Lata Mangeshkar, So the behavior of the, structure is like this, so you make sure that you are, moving the certain main beam elements in the main direction only, profound main directions, like that it is. I hope you are getting what I am saying. You see the natural behavior that this particular beam is a fixed beam. The behavior of this person is like, he is a cricketer, so let's not put it in some other place. So take the natural instinct of the behavior and then you apply certain, these kind of controlling situations, because it's sometimes, yes, it becomes risky, it becomes annoyed also, it becomes because it gives you this kind of warning, which Mahesh has told that why annoyed, because so many times you run the analysis, it gives you so many warnings. Why? Because you are not applying these parameters. These are compelling parameters, please understand. These are not the natural behavior. Natural behavior parameters, you don't need to do anything. You just run the analysis, get the results. So the behavior of the structure will remain same. The moment you give releases, you are telling structure you behave like this. It is like instructing a child that not to do like this and like that. That rebelling attitude will come over the period of time. So similarly, the structure will not rebel in that way, but it will give you so many warnings and instability issues and all actually. So how to correct that? You get the natural behavior first and then try to correct it in a very decent way. That's how it is. Yeah. Yes, anybody?
Sir,
Yes.
Can you hear me, sir?
Yes, Abrar. One by one.
Sir, when we are releasing moments at the end, when if we are not releasing the torsion, what will be the behavior at the site? How it will be behave, or we have to give any extra
No, site
reinforcement?
there is no behavior. On the site, what happens is initially during the casting nothing will, because there are propping, right? Back props and all. But later on, after the casting and after everything gets over, if you are not giving that anchorage, the rotation will start. That's what that's the point actually I have explained you just few minutes back. The rotation will start. The structure will start behaving, or structure will start acting rather. Acting means the work will done. Work means the rotation. You might have seen certain beams also, the structure is behaving like this. It will be, rotation has happened. Maybe you can just go to the Google images wherein you will see that the beam's rotation has happened on the site. Through that you can find out oh my god, I've given the releases, but on the site it is not happening that way.
sir, torsional release is optional. No?
Yeah, torsion release is optional, correct. Initially don't give the torsional release. Okay, but if there is a thin shell element slab is there, what happens is if there is a slab here and there is a beam here, let's say there is a beam here like this. If you are releasing the torsion, for example, what will happen is the slab will take the bending moment. So if there is a thin shell element at both the places, or at least at one place, that L action will happen, or the T action will happen. All right.
Sir,
Yes.
suppose that you have a continuous secondary beam, sir. Is it wise to release the moments in the continuous part, sir?
See, if you are giving the rebar straight, so that's what you need to imagine the site conditions. If you are giving the rebar straight, actually it will behave like a straight continuous beam only.
Yes.
Otherwise on the side you need to cut the rebar in between and again take the another rebar, like that you need to do, right? Otherwise it will transfer the bending moment. Another thing is, I will tell you,
Yes.
what happens is, even if on the side you don't cut it, for example, how much is the anchorage length that you need to calculate? If the anchorage length is less, you don't need to physically cut it. It will behave like a simply supported beam only, because it is not having a capacity to take the extra hogging bending moment. Understood? So even if on the side they do the continuous rebar, so it depends upon the width and that kind of action, that you need to see the realistic structure, take the natural behavior. This particular bending moment you require such a big anchorage, it is not possible to be there on the side. So let's consider this as a continuous simply supported beam only. After going for simply supported beam, you will get the bottom steel in a realistic. Okay, otherwise the bottom steel you are under designing it. That's the point which I have explained you. Please watch this kind of videos a couple of times more for you to digest it. Otherwise it becomes a big problem for you later on.
Yes.
Understood. See, releases function, if you know in the workshops, I have given 3 diagrams and we have wrapped it. But currently, if in the advanced and in certain sessions, we conduct this kind of thing when we come to the physical sessions. But I have covered most of the things right now. So I hope, it is easy for you to, understand it. Yes, any question, anybody? Yes.
So in case of sunken slabs in WC, do we need to give edge releases in the slab?
Yes,
Because they are,
it's preferred.
because we have not given till now.
Yeah, but how much that effect is coming, you can calculate it. See, what happens is, the effect is there, but it is hardly anything. If you are having a small scratch, you don't go to the hospital, right? Oh my God, take a surgeon appointment and all. So the effect is very nominal. Why the question is coming? Because you need to do that kind of practice. You add the releases or don't give the releases. What's the effect? You identify that. Oh my God, just forget it. Don't worry. Okay, but in certain cases, the effect might be predominant. So in that case, you need to calculate it. If there is a folding slab or it might be any kind of situation for any project. All right. Okay. Any question? Other question? Anybody?
Hello?
Yes. Yes. Yes.
Good afternoon, sir.
Good afternoon. Yes.
Sir, in RCC we have this simply supported beam and fixed beam. Sir, what is the difference? How we detail this? Where we detail this fixed beam and simply supported?
That's what I told you, no? The simply supported beam, the bottom steel will be more predominant. So at the center of the portion, the bending moment will be higher. So you will give additional rebars at the bottom fiber of the beam. But whereas the fixed beam, you require the additional rebars on the hogging portion, at the top portion also. So
some people say that only difference in the anchorage. So if you provide a good dedicated anchorage length for the development bond stress, then we get this fixed beam and simply support. But sir, there might be some issues if we don't provide the adequate reinforcement in the edges.
Yeah, I mean, I know what you are saying actually. See, what happens is, now this is very important point and this is very advanced point also. Please, pay attention here properly. Now, there is a incident that, let's say for example, this is the transfer girder. Okay, and this is a fixed element here. So in that case, you know that there would be, this kind of bending moment will be there. But if it is a simply supported beam, but if it is a fixed beam, what will happen is you will have the bending moment like this. So if you know the HRC committee in Mumbai, which is high-rise committee in Mumbai, what they do is, please mute yourself. Thank you. What they do is, if such kind of situation is there, we provide at this edge and at this edge there would be hinge support initially. So the bottom steel will be designed for this bending moment. There will be extra rebars, but the top steel would be considered it as a fixed. So even if there is a creep factor and some of the other factors are there, so what happens is, even if the releasing option is happening, the bottom steel is designed for that, because there is a huge amount of transfer girder is happening. Suppose if you do not consider this effect, because there is a column here, there is a fixed support here. So what happens is, this bottom steel, it will be, or the bottom bending moment will be transferred to the top, like this. This bending moment will be reduced. If it is released, what will happen? This is the bending moment. If it is released, if it is not released, this will be reduced to here, and this extra bending moment will be transferred to the top fiber. So what the committee, HRC committee, is saying intellectually is, let's say for example, you are having such kind of case, you give the top steel extra top steel like this also, and you give the bottom steel also like this, because there is a vertical point load here. So you are designing, because this is one of the key element, you design for this also and you design for this also. Always play safe. So even if, let's say, tension is there, right, huge amount of, so let's say there are huge amount of cracks has happened and all, the bottom steel will be taken care. Bottom steel will be take care of this particular cord. So there will not be excessive settlement that will happen. That will be discarded by them. This is one of the rule by HRC committee. Alright, so I think this would help you to understand probably certain concepts which we are trying to tell you. Because, anchorage length, how far it is true that will happen on the site, depending upon that, actually you will decide the bottom steel. That's what the question was, right? So how much is the anchorage length on the site and all actually will be provided, and how far it will be, considered to be the resisting element for this torsion, this tension. If it is not there, if you are not sure that this this extra rebars or anchorage will be there here, because sometimes the size of the columns is very less, this length is very less, there are rebars in the columns also. So you are not sure that this much amount of the anchorage length will be possible. Okay, no problem, you designed bottom steel extra for that. So there is no excessive settlement which will create the strain in the building. If the settlement is happening, it will transfer that strain to the upper floor, right? Any other question? I hope Sabdar, the doubt is clear. Yes, Sabdar, tell me. Yes, you can unmute yourself.
Sir, I was reading one book and there it was written that your secondary main bar should always go inside, below the main beam bar. With a longitudinal for the main beam bar.
No. The secondary rebar should come above the main rebar, not the below. I am 100% confident about it. The secondary rebars, let's say for example, this is the main beam, this is the secondary beam. The secondary rebar should come on the top of the main rebar, so that this shear force will be transferred to this. Understood? So in the slabs also it is like this, right? The secondary rebars has to be above the main rebar, so that the shear force will be from here to here, it will be transferred, and this rebars will take the shear action. Imagine this is not the situation, another is the situation. So let's say this is the main beam and there is another beam also. This is the main beam and this is another beam. This is secondary beam. Both are having same depth. So this rebar, which is the secondary beam rebar, it should not come down. If it is coming down, how the force will go from this rebar to this rebar? Understood? It has to come up. This rebar has to come up, so that it will transfer the shear force, the stresses to this rebar. So the secondary beam and this is primary beam. It will transfer the shear force from here to here. In the diagram it will be like this. Suppose if it is released, the force actually, the shear force of this beam has to be transferred to this beam. Okay. So please make sure that your concepts are proper, okay? Otherwise there will be huge problems. Alright, Subdar. Anybody else? 1 minute, I'll just... See, if you are asking the doubts, then only unmute your mic. Otherwise there would be so many... I know that many people are at home, so background music will be there. Yes? Anybody? Any doubt?
So for release and action fixity for frame members, if we give 0, is it constrained or restrained? Like if we put 0 value, it acts as single supported or fixed.
So you mean to say you are giving releases with the value 0?
Yeah, if we give 0, constrained value or restrained value?
So it is released.
Released,
yes. 0 means there is no resistance offered by the another element to this.
So if we give 0, it is fully released.
Fully released. Yes. Any another doubt? Anyone?
Hello.
Yes.
Sir, Deepak here, sir. Good afternoon.
Yeah, good afternoon. Yeah.
Sir, suppose we are providing a secondary beam as a cantilever. In that condition, we should provide end releases or not? If suppose there is a one beam is coming to a continuous and this is going to the cantilever portion. So in that cantilever, we can provide end releases or not?
And you don't need to. Even if you give, it doesn't matter much. So what you do is, if you want to have the severity of that, you give the fixed support. Fixed means don't give any releases. Run the analysis. Check the bending moment diagram. BMD diagram, you need to check it. Everyone. You should be familiar about the BMD, bending moment diagram. If you are familiar with the BMD diagrams, then it will be easy for you to understand the behavior of the structure. So many times when you go to the interview rounds, why they ask you the BMD diagram is because how much understanding you are having about the behavior of the structure. Understood? So what you do is, you run the analysis without any releases. Okay. and then take the call that whether it is required or not. I'll give you a right example, because I think through the example you guys will understand even further better. So let's say this is the example. I'll just delete all the walls because those walls are not required. Okay, I deleted all the walls, and I will select all the edges and make sure that there is no any edge release option is available. So I'll just reset all the default values, everyone, so that if you remember, I gave a certain release option over here. I'll take this column also down because I've done some nasty things here in the previous this thing. So this is okay. Fine. So if this is your model, and let's say we come to this part, I'll run the analysis quickly. You need to see the severity, otherwise there is no point in releasing and wasting your time. Please understand that. Sometimes it is easy to ignore. So let's say this is the beam, okay, and you forgotten to release it. How? And I'll just right click it and see that how much is the bending moment. So 13 kilonewton meter is the bending moment at this edge, and here it is 6 or 7. So this 13 kilonewton meter bending moment, it has to come down. That has not happened. So this is how much? 6 to 7 something, 6.01 or 6.1. So what do is we will unlock the model. We'll give these two beams as a released. I mean, this is before and after post release and pre-release information. So 13 and 6 was the bending moment. Now after releasing, what is the thing that you are getting? See here. So 13, 6 has become 15. Am I right? So this is the bending moment that you wanting to have it for this beam. So 6 kilonewton meter bending moment has become 16, which is huge. Whereas at this place it is 0, which is expected. At this edge it is, and this edge it is 0. Okay, so many a times seeing is believing. Okay, don't believe on me whatever I'm saying. You do the small your study for this, and then you make your own judgments. That will be staying with you always. Got it? Yes, any other doubt? I hope release is full released. No questions now. Yes? So that is known as crystal clarity. Okay, watch these kind of videos couple of times so that there are any kind of primary, secondary beams and all the things that kind of questions that you are getting or anybody is asking, it will be through. Alright? So please don't miss any sessions, post-lunch sessions also, like our civil studio sessions where we are doing certain small assignments. We are giving it to the students. I have identified some students are not coming there. Please do come there so that certain doubt clearing will happen there also. Okay, 4 hours a day you please spend up so that you will have a different understanding of the structures. So I hope you have enjoyed the session. Thank you very much. Okay, see you tomorrow. Bye bye.